Hello everyone, Rami, Assistant Professor of CSE Department from Rohini College of Engineering and Technology, subject code CS3501, Compiler Design, Unit 4, topic Optical Code Generation for Expressions. We can choose registers optimally when a basic block consists of a single expression evaluation, or if we accept that it is sufficient to generate code for a block one expression at a time. In the following algorithm, we introduce a numbering scheme for the nodes of an expression tree that allows us to generate optimal code for an expression tree when there is a fixed number of registers with which to evaluate the expression. Here show numbers. We begin by assigning it to each node of an expression tree a number that tells how many registers are needed to evaluate that node without storing any temporaries. These numbers are sometimes called Ershow numbers after a. It is used a similar scheme for machines with a single arithmetic register. For our machine model, the rules are label all leaves. The label of an interior node with one child is the label of its child. The label of an interior node with two children is the larger of the label of its children if those labels are different. 1 plus the label of its children if the labels are the same. Example, we see an expression tree with operators omitted that might be the tree for the expression a into b plus e of c plus t, or the 3 underscore t1 equal to a minus b, t2 equal to c plus t, t3 equal to e into t2, t4 equal to t1 plus t3. Each of the 5 labels leaves is labeled 1 by rule 1. Then we can label the interior node for t1 equal to a minus b, since both of its children are labeled. Then the rule 3b applies, so it gets labeled one more than the labels of its children, that is 2. The same holds for the interior node for t2 equal to c plus t. Here in this tree structure, it shows how the expressions are made. Here the interior node represents as a assignment statement. The leaf node represents as a siblings. Now we can work on the node for T3 equal to E into T2. Its children has labels 1 and 2. So the label of the code for T3 is a maximum 2 by rule 3a. Finally, the node for T4 equal to T1 plus T3 has two children with the label 2, and therefore it gets labeled. Generating code from labeled expression trees. It can be proved that in our machine model where all operands must be I registers and registers can be used by both an operand and the result of an operation. The label of the node is the fewest registers with which the expression can be evaluated using no stores of temporary results. Since in this model we are forced to load each operand and we are forced to compute the result corresponding to each interior node, the only things that can make the generate code interior to the optimal code is if there are unnecessary stores of temporaries. The argument for this claim is embedded in the following algorithm for generating code with no stores of temporaries using a number of registers equal to the label of the root. This is the algorithm for generating code from a labeled expression tree. A labeled tree with each operand appearing once, that is common sub-expression. An optional sequence of machine instructions to evaluate the root in the register. The following is a recursive algorithm to generate the machine code. Here the steps below are applied at starting at the root of the tree. If the algorithm is applied to a node with the label key, the only k registers will be used. To generate machine code for an interior node with the label k and two children with the equal labels which must be k minus 1 to the following. Recursively generate code for the right child using base b plus 1. The result of the right child appears in register rb plus k minus 1. Recursively generate code for the left child using base b. The result appears in rb plus k minus 2. Generate the instructions where up is the appropriate operation for the interior node in question. Suppose we have an interior node with the label key and children has with unequal labels, then one of their children, which we will call the big child, has label k and the other child is a little child. Recursively generated code for the big child using base b. The result appears in generator rb plus k minus 1. Generate the instruction rb plus k minus 1 or the instruction depending on whether the big child is the right or left child recursively. For a leaf representing operand, it is a base b is a generate the instruction ld. Ld represents load rb comma x. Thank you.